Okay, so we have a small amount of PowerPoint just to take you through what we're going to go through today, and I'm backing all of this up with some whiz-bang slick demos from Dave shortly as well to follow each section. So with that, we're just going to start off with just a few pointers, really, a starter for 10. So when we look at what we've had over the last 20 years in our HMI platforms, we're starting all the way back. I mean, we're going back 20 years now, all the way back to the world of Pro Tool on very early OS platforms. And even back then, we had migration platforms to bring us through into WinCC Flexible, which took us all the way through to 2008. And then more recently, of course, into the world of TIA Portal. Now, many of these were, as you can see on screen there, just with one click, we could get a migration. This is really true for a very high percentage of applications. So some undoubtedly need a little bit of additional work, but for the vast majority, a very seamless and easy way through. If you want further information on migration, I've put this web link up on the screen here, where you can get a lot more further information on how to do it, some good tips and tricks and things like that. But of course, moving on into the future, nothing's going to change with our new unified platform as well. So with unified, of course, we have the openness integration as well, which we have this bolt-in called Data to Unified. This is an add-in into TIA Portal, which can take our project and bring that through into the world of unified panels and PC runtimes. Now this is going to be adapted. You can see it there in the web link on screen. Now this will get enhanced further and further and increase in functionality as time moves on. So just moving really talking about a little bit of some of the other great features that we have built into with our panels. And one of the really key things for me in particular is the safety integrated option. Now here we've got things like the membrane keypads as the KP8 and the KP32s. Now these have wiring terminals in the back where we can actually wire safety devices or a safety emergency stop into them. And then the safety data is transmitted back to the safety PLC and processed there. So this is really great interaction for things like remote consoles, desks, things like that. Really great feature to be able to wrap everything up together and process all of that inside the HMI. Other things like the new the mobile panels we have as well with the integrated emergency stop and dead man handles and things like that. This is really great feature. These are Ethernet based, okay, and these are a great addition if you have an application where you need a HMI in multiple places with safety on it, but you don't want to put a HMI actually physically in every place. So we can have connection boxes dotted around the place where we can connect the HMI into and decide whether the safety emergency stop that's on the device is active or inactive. And this both works depending on the connection box with a safety PLC or a traditional safety system as well, a traditional hardwired safety system. So very flexible in design as well. And then that brings us to the new Pro panels as well. So the Pro panels, again, have these great screens, great graphics, brilliant environment. But we also have these additions that can go on, bolted on the bottom here, where you can configure this to your own like. Okay, where you can decide what buttons, what color of buttons, key switches, selector switches, and as you can see here, safety integrated options. So this will be a Profinet device, I/O device, which is actually bolted to the panel, and again reports back all of its information through to the safety PLC. So very, very flexible, high flexible options there with safety integrated in our HMIs. Now, when we're talking about safety, and certainly with HMIs as well, then of course, security is a really big point and a very strong point for Siemens HMIs. So as you can see, there's layers and layers of things that we can go through on here. We'll start at the bottom. So basic things like password protection and the ability to be able to deactivate the online transfer, so remote transfer for upgrade and modifications of the panels, so that can be locked down. The PLCs themselves as well can provide an interaction. So this is great with an integrated project where the HMI actually has to pass a password through to the PLC before it can establish any form of communication. And so this is great to make sure somebody can't come along with an ad hoc HMI and try to gain access to the controllers or manipulate the controllers in any way. Natively within the software, the configuration of both the PLC and the HMI, which interact seamlessly together, is the user password access control. So in here now, of course, we can set up passwords and levels of control and operations in terms of user roles and defines and definitions. And we can set these up so only the right person has the right access. Now, the great thing about these as well with the passwords, as well as we can also link these to an Active Directory as well. And utilizing Somatic Logon, we can connect these into Windows environment and bring all those Windows user credentials down into the HMI. Which is then really great because then we can also group these together and we can allow certain employees access to certain machines, with maybe machines that they've been trained on, for example, and also people who could change the levels of what they can actually do on that machine as well, whether it's operate, whether it's engineering, whether it's maintenance, all those sorts of tasks. This is also very, very important to make sure we lock down this display and the users, especially if we are going to connect it to higher level systems or remote systems. Okay, so in the world of service and support and remote access to these panels, it provides these great features, but we also have to make sure that we are secure. Okay, so this could be a local Wi-Fi communication where we could use the smart access. We can actually remote control the HMI or gain access to the HMI for service operations, but also over a public network utilizing VPN technology and secure communication as well in such the same way. If you needed more information on Security Integrated, again, we have a web link here on the top here, which will give you even more information. Okay. One of the great features of our panels, all built in on the comfort panel and upwards, is the integrated system diagnostics. As you can see there on screen, you have a singular control object which literally drops in and gives us information and status on based around the hardware of our system. Now, the reason we've included this today, we see so many of our customers who still don't use this fantastic feature. Now, we have an object here which basically gives us a nice tick or on the health status of the system, or a cross in this case, and we can basically freely navigate ourselves around all of the hardware that's within the system and giving us all that great information and logical information. Now, with a singular error in the system, we could click on this button and it would take us straight to it. But again, as I say, with multiple errors, you can freely navigate yourself around the system. And the best part about it is we're not dealing with error code. You don't have to refer to a manual to go and find out what the actual problem is. It will return it natively in plain text, okay, to give you an easy fault analysis that anybody should be able to understand. And Dave is now going to give you a great demo and show you this in full working order.
Thanks, Andy. So the important thing to set up the integrated diagnostics is to create a connection between the PLC and the HMI. So when you're creating connections in your networking devices and networking tab, just simply go on to connections. Everything that can be connected together has now gone this cyan blue. Any connections that are pre-built, if you just highlight them, you can see now that we have a connection between the HMI and that PLC. But also a really nice feature with a integrated PLC and an integrated display is that we can use routed connections. So at the moment, you can see that these two PLCs are not on the same network. They're not on the same Ethernet network. If I highlight it, I've already formed up one routed connection. So the connection is actually routed through this PLC to there. So they are actually on separate IP addresses. So the IP address of this is 10.15 and this is 0.13. So they are not on the same subnet IP-wise, but they can still talk to each other. So how do we set up this routed connection? It's dead easy. You just select your PLC, you drag to the HMI you want it to talk to. When you have connected it, it says, do you wish to add that as a routed connection? So I click that, add as routed connection, and you can now see that it's put in the symbols and we've got our routed connection between the two PLCs. So it is that easy. Now it doesn't have to know about IP addresses or anything. It's all dealt with through the PLC, and that HMI will now talk to a PLC that it isn't even connected directly to. So how do we now put that the display screen? So I've got my screen here, and simply you just pick the doctor's stethoscope here, drag that object out and drop it on the screen. That is all the configuration that there is. And then what you end up with is this as a display. Obviously I haven't downloaded, so I haven't got my third PLC, I've only got my two. But if I now generate an error in my system, we can see straight away that we've got our error. We can now follow the red. So we can see in here, we've got a problem in our system. We've got a card that has been removed. So it's a really simple way for me to build a error and build it in. One problem that people do come up with and ask about, it's not necessarily integration, but they do ask, how do I actually see these errors, these same diagnostic errors in my actual program if I want to take action with that? So we do have some code blocks for that, which are called, there is an FAQ on this, standard diagnostics, and these use these module state, which gives us the state actually inside a station. And then we've got our device state. So these are the individual states of everything that's attached. So if we just go back in, I've just drawn some simple graphics. We can see that we've still got that problem inside. So it's identified that the station's got an error. If we click into the station, I've just done a simple pop-up and it's the number of slots that are in that station and it gets that error. So these are just bits that can be used inside the program to take the integrated diagnostics, hardware diagnostics, and actually use them to affect the actual control program. So with that, I'll hand back to Andy.
Right, that's great. Thanks, Dave. So great use of the integrated diagnostics and also the program functions as well to utilize without your code. That's great. So taking this all a step further now. So we've seen this is obviously the alarming system we need to move into now. So you've seen the controller alarms in the first slide. Now, these, of course, as you can see on the graphic on screen there, are generated from the controller and rippled out throughout all devices that are connected. Now, you've probably seen this slide yesterday, I think, when I was watching on yesterday. So we're just going to put a slightly different spin on this slide. We're going to talk really more about the system-wide display and acknowledgement. Okay, so on all the devices here, what we're going to do and talk about now in the next slide as well is moving away from doing the alarming based directly on the HMI system and doing it more in terms of inside the PLC along with the controller alarms. Okay, so this means that then when we generate an alarm, it's generated at the controller level and then pushed out to the HMIs, which all have the capability to read this alarm in as a textual format and display those alarms. This gives us some great benefits. So all of the timestamps and things like that will be synchronized based on the controller's timestamp, not the individual timestamps at the respective HMIs. It also gives us other benefits such as to be able to do this system-wide acknowledgement. So when we are looking at it, say on this device over here, if we acknowledge an alarm, then of course we're acknowledging at the controller, and the acknowledgement will then be pushed back out to all of the other HMIs. So you don't have to go around acknowledging on various different HMIs. It also gives us additional benefits, such like if we were viewing through the PLC web server the alarms and we wanted to acknowledge at that point as well, that would again acknowledge at the controller and push all that acknowledgement out to all of the connected HMIs. When we do all this sort of stuff as well, it would also be a great thing to deploy alarm grouping and utilize the alarm classes. So we can break these things up into areas of plant or types of operation, like motors, valves, tanks, those sorts of things, in order to be able to filter in these in the right way, so as an operator can very easily work through all of the alarms and find the issue of the problem very quickly. So we've just mentioned about PLC alarms. Okay, so PLC alarms gives us the capability to utilize the FB700 function inside our code. So when we talk about our code, so if we were making a function block around, for in this case, a valve or a motor or a tank or whatever it may be, we've got all of our logic there. So, okay, so we've got all of our control, we know all of our status, everything's already built into that one function block that we're going to utilize and deploy around our code. So by adding into that code the program alarm, as I say, this is FB700, which is from the standard instruction list in the TIA portal catalog, we can add in the information to control this alarm on the sig pin there, the signal pin, and then we can then build this program up, alarm up in our valve FB. What's really cool about this is the capability to be able to then parameterize this alarm inside this instance and put in some static text, put in some keywords. So the keywords are really important. So we can add things in like the PLC name. So whatever base we give the PLC name, that then would ripple through. So this means that we get this really nice symbolic reference with our alarm in a unified format. So we can see other things like the program alarm name. So that would be this in this instance. Okay, and also instance and path. So the symbolic references to the function blocks that are being called. But again, because we were really focusing around the alarm classes, program alarms can also conform to the alarm classes that we define. So here we can see we put this into the valves alarm. So this is really great for building up standard architectures for alarms. Things are especially conforms to multilingual options as well. So if you're shipping your panel overseas, that would be also really key as well. So Dave's going to take you through program alarms now with again another nice sexy demonstration.
Thank you. Right, so the first thing that we set up if we are looking to build a integrated alarm structure across our different PLCs and our HMIs is set up some alarm classes, because this enables us to filter them. By default, there are 2 alarm classes that are built into TIA, which is an acknowledgement and a no acknowledgement alarm class. I've put 2 more in. So I've put in an alarm class called valves, an alarm class called hardware, and I've made that there should be an acknowledgement for an alarm which comes in the class of valves. How do we then use these inside our HMI to filter? So if we actually go into a screen, you select the alarm control, which is this control here, which has just been dragged out and put on the screen. And then in the properties, the general properties of that alarm control, you get the option then, which alarm classes do you wish to be displayed in that one? So in this particular one, we will see hardware faults. And if I go to my program alarm screen, we will see that we see valve faults and just valve faults inside here. Again, Nick Stewart did a fantastic demonstration earlier on in Tech Talks of how these program alarm blocks are used. but just a quick recap so you can see how they're used. I've built a function block called valves, which I have got the program alarm block here, and I'm just simply using a delay when I request it to open. Has it opened? If it doesn't open after the delay, then it will generate a fail to open alarm. I've then used that. So if we just see how we've set that up, you can see I've used the keyword of instant and path and some fixed text, just as Andy said. I've then used that in a function block twice called my tank, and in there I've got an inlet tank and an outlet tank, and then I've taken that tank and I've further embedded it inside a tank farm block where I've got a number of tanks. So you can see tank 1, a water tank, and then an oil tank. So what I've then done in my main program is I have called the valve block first one, and it's called main incomer, and then I've got an interesting one, a beer tank as a tank, so it's a valve, a tank, and then I've got my raw materials as my tank farm. So if we actually see that in operation now, if we go into the runtime, so on the main one, this should be a main incomer. So after 2 seconds, we get that it's taken the name main incomer, inserted it into the text string. My tank, as I said, something a little bit more interest. Beer tank has come in, so I've got a beer tank as a inlet valve. So it's say appended those in, and then we can go one further. So we should have our raw materials tank 1 inlet valve. So all of that has been pulled out of my program and displayed. Now, the real power of the integration is, as Andy said, these timestamps would appear across all HMIs. So if I had 3 or 4 HMIs, and I could actually acknowledge these from anywhere as well. So if I bring up the web page of the PLC, we can see exactly the same alarms have appeared into the web page. At the moment, all the alarms, I haven't clicked acknowledge. If I acknowledge in here, they are acknowledging into my HMI. So that means that when these alarms disappear and I turn them off like this, they disappear from all HMIs. So you don't go into an MCC room with a HMI or something and have 6 months of alarms all sitting there waiting to be acknowledged because nobody's been in there and acknowledged them. They are acknowledged system-wide. Real power of integration. And just for the alarm classes, if I bring that up, go back to my system, we don't see that error. If I generate a hardware error, so there's a hardware error, so it's filtered on there, go back on here, not in here because it's using the alarm classes and it is filtered. So with that, I'll hand back to Andy.
That's great, Dave. Thanks very much. Right, okay, so that was a great introduction to program alarms. As Dave says, there's other meetings that you can see and tech talks to see this in much greater detail if you want to go back and take a look at that. For us today, though, we're just going to move on another layer now, and we're just going to move into ProDiag. So again, fundamentally, this again is an alarming system. Works very similar to PLC alarms, as in it is designed and constructed in the PLC area, not the HMI area. But this is much more of a configurable alarming system. So when we're actually at the point in our code, we actually can go onto the tag or the coil or whatever it is, and then we can click on and add a supervision. Okay, so we're actually defining the point that the place in the code where we're actually going to monitor this. Okay, this gives us some great features when we take this up into the HMI level. Some of the key benefits about utilizing ProDiag over PLC alarms. Now, PLC alarms are S7-1500 only, as is ProDiag, as you can see on screen. The difference with ProDiag is if you've got supervisions defined and you want to use that function block in a 1200 PLC, it will allow you to do. We'll just strip out the functionality. So then that your code is transferable between the two PLC platforms, whereas program alarms, you would end up have a problem there and you wouldn't be able to compile your software. Okay, so some of the other real key features based around the PLC environment is that there's the program alarm, of course, has a loading on the PLC because you are calling it as code on a cyclic basis. With ProDiag, what it actually does is automatically generate an OB that's running in the background for you and calls all of the alarming features at a slower rate, a slightly slower rate, which then means that we have less loading on the system, and it means that we can deploy even more alarms which is really great for bigger systems. Okay, so why ProDiag though? So this is great. So we've defined it. Which is again, it's more of a configurable system. But the real benefits come when we look at the HMI. So we get control here. Apologies for it being in Germanish, but here where we can categorize the alarms for errors, warnings, and information, and also break these down even further into operands, reactions, actions, those sorts of things. We can also have additional ones where we can define them our own categories if we wanted to. But effectively where this one's really strong is the fact that we also have the code viewer capability within inside anything from a comfort HMI and upwards. So this allows us to be able to actually, because we've defined the point on the tag or a point in the code where we are generating the alarm, it gives us the ability to actually be able to jump live on screen to the code and show it there. Okay, so we can actually get great information without the requirement of an engineer. Now, we will have additional language in the 1500 controllers called S7 Graph. Okay, so when we're utilizing it with S7 Graph, we can actually see the step information. So this is a cause and effect chart, flow chart, sequencing, and the data I'm going to take you through shortly. So we can see what step we're in, where we're up to. But again, we get this great information where we can see here on the left-hand side our whole sequence, where we're at in the sequence, and also, we can define that if we're in this sequence for too long, then we can make this error and generate an alarm. When we click on that alarm, we can then open up the code in the right place. Now, in this instance, this is what I've done. It's actually sat here waiting for an operator to make a decision on whether I want the orange light to come on or the orange light to flash. In this case, I just made a very, very simple traffic light system. Okay, and we can see here the detail of what the transition steps, which is here and here, is waiting for. Okay, and we can see these highlighted, and we can see the step information there. Okay, so Dave's going to take you through this live in more detail and show you how to configure it all up.
Okay, thanks, Andy. So the first thing that we do with ProDiag, we have a common area, again, down in this common data, just exactly where the alarm classes were. And this is where we set up our alarm classes that we want to use, so which of the defined alarm classes we want to use. And we also pre-set up our alarm messages. So all the alarm messages will be a consistent standard across all of our PLCs and all of our HMIs. So we define what we want our alarm message to be once, and then it is used across all of the PLCs and all of the HMIs. We can also export these settings, so we can just export these settings out of this project, and we can then have common alarm settings by importing them into every project that we do. So that would mean that all the alarms across the entire site would be a common structure, and everyone would be used to the different alarms and what they mean. So to actually set these up as a ProDiag alarm, you can, as I have done here, build a motor function block. If you notice, I haven't actually put any code into the function block that would control the motor, because all I'm trying to show you here is the alarms. So any of these inputs that have actually got alarms, ProDiag supervisions on them are marked up with this symbol here. If I first of all select the tripped signal, so this trip signal is what we call an operand alarm. So we can have these different alarms. Don't worry, I'm not going to go through every one. I'm just going to show you a couple of examples. But the operand alarm is something that generally just comes on immediately. So what I've said here is that signal becomes true immediately, so there is no time delay. I want you to generate me the ProDiag alarm. My other alarm in here is going off the command signal, and this is a reaction alarm. So a reaction is testing, did something happen when I asked it to happen? And so what I've said here is when my command bit goes true, I expect to see the running bit become true, so not be false after 5 seconds. So I'm giving it 5 seconds for the motor to start running. So it's doing all this code for me. I'm just filling the boxes out. There is no PLC code. It's all just done as part of the supervision. So then we can deploy that onto our screen. And as Andy says, we have a number of things that we can deploy. We have our overview diagram. We have our code viewer. We still have our standard alarm screen that will generate the errors. So let's actually see this in action. So if we just go in there, so if I have a trip, I expect to see a trip straight away, and it did. So we've got an error. It's an operand error. Straight away, we got our fault in here. I can request to see that code. Obviously, it's just straight on. Let's have a look outside the block so we can see here. And this is a live code viewer. So if I turn off the motor tripped, you'll see that the motor tripped turns off. If I ask the motor to run, so the motor run has come on, because I haven't programmed in my feedback, it's obviously going to generate my error. So after the timeout of the error, we've now got an error. It's a reaction error, and the error is that the motor hasn't run when it's been commanded to run. So that has all just been developed up by the ProDiag, and I can see the code. The final demo that we're just going to show here is a graph error. So I'm going to generate an error in my graph. It'll just take it, it's running around the sequence. Here we have a problem in the graph. If I again request to see the code, just make this a bit more obvious, you can see that we're in our transition. And in our transition, I have generated and put a blocker in my transition. So now the step is timed out because it can't move out of this transition until this is true. So if I reset that error, what you can now see, it's moving through, and then you can, in a live sequence, you can see it moving through the sequence. So if this was a more complicated sequence, just like Andy's traffic light, we could actually follow it and see the inputs and outputs coming on. So hopefully that's just taking you through ProDiag. So with that, I will hand back to Andy.
Right. Okay. So that then brings us to our next point that we wanted to go through, which is, of course, the efficient engineering. Now, the great thing about an integrated project with Siemens is the capability to be able to take tags from the PLC and consistently map them across into the HMI with a simple drag and drop. Drag and drop even. Okay, so this means that the tag reference is pulled through into the HMI area. They're symbolically named exactly the same. But where this really gets interesting is when we just want to do this with something with what we call a PLC data type. So we can see here we've got our PLC where we've got a structured data type, and that could be an integer, a boolean, a real, whatever, but all done as a PLC structure. Okay, so the PLC structure can also be mapped through into the HMI. And then we can utilize it. So this means really efficient engineering, and especially when we're utilizing it in conjunction with things like faceplates. Now, what's really, really great in these is when we make a change. So when we move through into the PLC area and we add something even in the middle of that structure, With a simple recompile on the HMI, that structure is then passed through and updated. Okay, so this is really strong, really good, very good for time saving. But the most important thing is making the whole project consistent and your engineering consistent, so we don't make any mistakes or any problems, things like that. Okay, the next part is where it gets really interesting. Okay, and this is where we're going to look at tag indexing. Okay, so inside the PLC environment now, what we've done here is we've made an instrument in terms of a tag. Okay, and we've made this as an array. Okay, and the array, as you can see here, has got a symbolic reference here. I think we've made it about 10 long. So we've got our data type, which is our instrument DT. And you can see the various different types that are built into there. And of course, we have the array. Okay, so now in terms of the PLC, in what we want to see in the HMI now, we could make that tag and drag this tag, say instruments 0, into our HMI. Now, if we wanted to display all of these instruments on our HMI, then we would have to utilize, every single tag. Now, of course, this is going to hit our tag count quite hard. Okay, so there's a better way of doing this, and I think Dave's going to show you a way utilizing it with things like pop-ups and things like that. So what we can actually do is index this tag, so we can populate the actual faceplate with an index reference of here. So we'll reference back to the PLC, back to the array. And the way we do that is by going into the definitions of the tag. Okay, for those of you who don't get tag indexing confused with multiplexing, because that was another option. So this is under the generals information here. And then we come into here, we can see the address is the instrument data type. And we can see here, we've got this brackets index. Okay, so when we go into this PLC tag here for the indexing, okay, again, this is why I say don't get confused, because it does say multiplex there. That's not the same as this thing over here. Okay, we can then process an index tag. So this would be like an integer where we can effectively populate which of the array instances we actually want to be pointing at. So this means that we can then utilize one set of tags to be able to point at different references from our PLC code. So great for pop-up information. A great time saving and great on your tag count. And Dave's going to take you through the setup of all of this now and go through it as a full demonstration.
Okay, so what I've got here is, first of all, is my data type. So this is down in PLC data type down here. So what I've done is I've created a data type, a bit, an integer, a floating point. I've then gone into a DB. And what I've done is I have created that as an array of data. So we can see here I've got data type, and it's exactly that data type all the way through. Now, if I want to take that into my HMI, what we do is we can go into the HMI. This is the HMI tags. We can go into the data block using our nice little detailed view down here. We can take one instance of that, and we can drag it up here and we can drop it in. And what you can see is it's actually built it using that PLC data type. So what we've got there is exactly the same data type that's in our data block that is defined down here. So if I want to now go and add some more data to that data type, I need to change the data type. I go back into my data type. I can say add a new row to that. I could put in here new data. We'll just leave it as another real. And now if I go back into my data block, we can see we've got a problem, because what we need to do now is just select that and recompile that data block. So that's now cured that problem, because that's now changed us. We now have our new data here. But if we go back to our HMI, without me having to do anything, because this is all linked together, you can see it's already built that as a new tag inside my my HMI. So That's really good. It means everything stays in sync and everything's linked together. But as we were saying, we want to push this a step further. So what we now want to do is we want to be able to go up and down this array index here to these 10 items here and look at each of these 10 items on the PLC, on the HMI. So what we need to then do is click into here, go into properties, and in this box here that is often blank because we don't use this feature, we go into, so in the general settings, in address, we pick there, and we pick that we want to display this as a tag. Now what we will then have is we need to have a tag, something like index, that will move us up and down this array. So this is the number that we're going to put in here. So if I click on that, you can see now that that's moved that, and that is now a multiplexed tag. Now I just to neaten it up for myself, I take off the 0 that came up. And here is just another tip. Even if you've got 10 items in your display, just always put in a 0, 1, because when you bring the array index, when you do this, the HMI always starts at 0. So if you do a 0 to 10, but only then put a number in of 1 to 10, it just makes it easier to understand. It's just a little tip that helps you out and avoid confusion. So always number your arrays inside your PLC as 0 to however many items you want. So by changing that array, that index now, we can move through. So how does this actually look like? What does it actually look like in operation? So what we've got here, and just to show you inside my screens, I have a single pop-up. So I've designed a single pop-up, which has got all the information. It's got everything, but it's looking at this one setup, this one multiplexed tag. And then all I then do is in here, when I click the instrument, this is the slider for 1. You can see that it's reacting to instrument 1. But when I click 2, this is exactly the same pop-up. I haven't redrawn it. It's just putting the information into the pop-up. So I can now affect instrument 2 or instrument 3. So I can have as many instruments as I want and just call the pop-up and drive that information in there. I've drawn the pop-up once, I've tagged it up once, but I can now display numerous instruments inside that. To take it one stage further, I created 4 of these multiplex tags. I've put it down 4 individual times, and then what you can see is you can move through all your different instruments, and this could be arrays of objects, this could be drives, the setup of a drive, the ramp times or whatever. And this is one screen. I'm just moving the index number that I move. I've got 4 different indexes, and I'm adding 4 to each of the indexes and moving through it. So I could have an infinite number of instruments and just keep indexing the number up in groups of 4 and displaying all that data. But I've drawn that as a single screen. So inside my screens, you will see down here, this is it. This is just a single screen that I am displaying multiple 4 of items. But as I say, I could have 400 valves that I just tag through. Take me a bit of clicking to get through, but it is that easy to build multiple tags onto a screen. So with that, I'll hand back to Andy just for the conclusion.
Basically brings us to the end of our presentation for today. So we